it took me a while, and I think it takes a lot of folks a while, how to really write an industry-friendly resume. Because you might think, you write the resume and you think it's good, but it's still there's way too much astronomy jargon. There's way too much, assuming that people are going to care about your papers. I'm sorry, they don't. Then again, if you want to be something, if you want to be a data scientist, data engineer, pitch yourself as it. Like, you're not a student trying to do these things. You are the profession.
Welcome to the Astronomers Turned Data Scientists podcast. I'm Joseph Ahern, and I've been a data scientist for 2.5 years now.
And I'm Jeff Silverman, one of your other hosts, and I've been a data scientist for over 8 years now. I can say over 8 years. We're in the new year, so there you go.
Our guest today is Patrick Aleo. Welcome, Patrick.
Thanks for having me, guys. It's a pleasure to be on.
One of the reasons we wanted to bring you on, especially, is because you transitioned to data scientist more recently than any other guest we've had so far.
Honored to take the title on the show. That's awesome.
Yeah. So 1 year ago, more or less.
Just about. I defended my PhD in astronomy March 11th of 2024, and then started my job as a senior data scientist at Honeywell Federal Manufacturing Technologies on April 8th. So not even.
More recent than I thought. Yeah. Cool.
Yeah, Patrick was a speaker at Astronomers Turned Data Scientists 6. So just over a year ago, he was a speaker at that. He was our token astrophysics researcher speaker at the time, and then announced in that talk that he had received a job offer, which was lovely, and spoke a little bit about his job search at the time. So we'll put up the link to his talk from last year, but we'd love to hear a bit of an update on that and maybe go into some more detail. So why don't you start us off with sort of, what you did in astrophysics research and sort of, where you came to the conclusion that you wanted to move towards the tech industry.
Sure. So I would go all the way back to the senior year of my undergrad at the University of Texas at Austin. And I had an advisor who was really in the know about machine learning. And I never heard that concept before. And he was talking about all the applications to other fields like the medical industry, doing machine learning for like cancer detection and all of these things. And he was applying those same techniques to astronomy. And I thought that was super cool, very novel. And it was at the tail end of my time in undergrad. And so I kind of had it in the back of my mind because I was learning a lot about it, thought it was very interesting. Get into grad school, and I spent 2 years at the Advanced Visualization Lab at the National Center for Supercomputing Applications at the University of Illinois, Urbana-Champaign. And I was taking the approach of, can I do some very simple machine learning to inform cinematic astrophysical data visualization? And so I did a project with the group over there, taking a pre-existing video of a moon formation and using machine learning informed decision making when it comes to, how are we going to highlight particular accents of, say, temperature or density or pressures that would be appealing to a visual audience while also staying true to the science behind it. So it's like, not to take away the efforts of the skilled technical artist, but as like a starting point that kind of marries where, a scientist could make more powerful visualizations. And so that was kind of my first machine learning project. And ever since then, I always implemented some kind of big data, machine learning, AI, you name it, into my work. And from there, after 2 years, I transitioned into supernova science, coming up with algorithms for classification and anomaly detection and similarity search work. And I was like, this is my bread and butter, where I was more interested, I think, by the end about the statistical techniques and the applications. And the domain, at the time was astrophysics, but I knew that just because I'm a lifelong learner, I would be happy to apply those techniques and those approaches to other industries, which was, my first exposure to them all the way back in undergrad.
Awesome. Yeah. So I did my undergrad at University of Illinois at Urbana-Champaign. And so I did the physics major, but with the astrophysics technical option. So I'm familiar with the
Beautiful.
astronomy
Yeah,
department there, and the I didn't work at the supercomputer at all, but I know some people who did, and so yeah, it's neat to
have that
to
spot of connection.
have
Yeah.
you on who went to grad school there.
I mean, if we're
Yeah.
gonna keep going with that thread, Patrick,
Yeah.
have we talked about how we overlapped at UT? Did we realize this?
I don't know about the year, but certainly I knew that you went there. But yeah, I was there from 2014 to 2018, and so
I was there from 2012 to 16, and my office mate was Ivan Ramirez.
wait, really? Yeah, because he
Yeah,
was my advice. Okay.
right.
Oh,
So
that's amazing.
I was looking up your papers just now, and I was like, wait a minute, Ivan was my office mate. I was there as a postdoc, so there's a
Yeah,
very
because
good
he was there as a
chance
postdoc too,
you
or
were
not a
in the
yeah.
you were in my office, and just we did not realize it, a decade ago or almost a decade ago. So,
Crazy.
well, excellent. It's a small
Long
world,
overdue.
as we all
Yeah.
know.
Yeah.
Yes.
That's cool. Yeah, we didn't overlap there because I finished in 2016 and started grad school. That was
That's
before
good
you
to hear.
got there. Yeah. But yeah, very cool. One of the things I liked was, we're a bit away from Chicago, a couple hours away, and so you can get some dark skies out there and rekindle that love for astronomy. Just, the origin
Absolutely.
what originally sparked it in a lot of us. So,
Yeah, and that,
mhm.
that that was true for me too. I mean, I think it was about fourth grade when I started getting interested in astronomy. I like to talk about three separate events that really kind of led into that, where I was a fourth grader and I was taking out the trash one night and, dark, clear night. And I was taking out the trash with my brother, and he must have been learning some very basic astronomy in middle school. And he was like, oh, if you look up at the night sky and you look at the stars, you're actually looking back in time because it takes light, you know, so and so long to get here. And I was like, how can you be in the present to look in the past? And that like blew my mind out. And I kept thinking about that. And there was another time where the same brother, Nathan, this was maybe 6 months later, we were at a religious education class. And before the class started, we were just given a quick assignment of, oh, turn to your partner, turn the person next to you, and tell them something that they don't know before, like teach them something new. And again, he must have been in this whatever astronomy class or science class was talking about galaxies, and he was like, "Oh, it's not just stars in the night sky that's in our solar system. Like all those stars that you see are in our galaxy, and there's a lot of galaxies in the universe." And I was like, "Oh, I didn't know that. I thought it was just us and the solar system, and then stars. Like that was it." So that really expanded my conception of the universe and how big of a scale it was. And when it all came home for me was that same brother, it was his birthday, I think like a year later. And my parents got him a small toy telescope. And so we waited for a clear night and we took it out. We looked through the telescope at the full moon, and I was transfixed. I was like, it was always something that was just out there, but it felt tangible. It felt like I could reach out and touch it. And I was hooked from then on. So I was like the fifth or sixth grader, but the parents, would come up to you and be like, "What do you want to be when you grow up? When you get older?" And I was like, "I want to be an astrophysicist," like a super nerdy little kid. And they would be like, "What's that?" And so I'd go on a whole, tirade and tell them all about it. And so I knew kind of as a middle schooler, I was very driven. I was like, I need to get my PhD in astronomy, and I want to be an astronomer. And so that was like my lifelong goal up to that point, which I just, succeeded in that not too long ago.
So, a lot of people have that kind of story, right? In astro research and folks outside of it, that is not too dissimilar from my story growing up, for sure. And clearly, you still love it and are, fascinated by the scale of the universe and those facts. But you're not doing that for a job anymore, right?
Correct.
And I went through this. I don't know if it's a paradigm shift or this sort of at some level crisis of faith, to go back to your religious studies class, but of I love this subject, I want to study it, I want to learn more, but I don't want to do it for a full-time job, and how do I, square all of that? And so I'm kind of curious to hear, sort of your thought process of, you really liked machine learning and applying these to astronomy and realized you could apply it other places. But then how does that jive with, hey, I also love space and find it fascinating and want to learn more about the universe? And sort of, what was your headspace then, and sort of what's your headspace now around that?
It's a really insightful question, and still mull about it every now and again. But I was always, the love is still there for sure. But I'm a lifelong learner first, and I feel like, especially now, like retroactively looking at the PhD, I feel like I succeeded what I set out to do. Where, not to say that there was more that I could have done, because obviously there's always more to do. There's always more research to be had. There's always more insights. But I feel like my goal as a PhD researcher was truly to develop some novel algorithmic models to discover some things about the universe that nobody else has ever discovered before, whether that be actual discoveries of supernovae that were hidden in these big data sets that people just hadn't discovered before, or in the night sky being the first one to call it, say, hey, this thing is acting weird, let's go direct some more telescope time at it. And I've always been very proud of that. And I just feel like I kind of have gone on that journey. And although, there was more I probably could have seen myself end up doing, I was very content with the point to which I got it. And I was like, okay, now that's, I can, like, in a sense, check that box off, and what's the next thing I can just really dig into and really sink my teeth into something new, and to see what kind of fresh approach that I bring at it. And I feel like that's going to be the case for the rest of my life, because like I said, I just want to learn new things and want to apply techniques in new ways, and I want to discover things that nobody else has ever discovered before.
So when you were finishing up your PhD and thinking about what the next step would be, did you weigh the different options? What were some of the more practical steps that you took in applying for a job, or like to get to that point?
Right. So it was, I would say, maybe it was really pretty on in my PhD, first or second year, where I was committed that, like, yeah, after this, I probably want to go into industry. And I think when I joined my eventual PhD advisors research group, Professor Gautam Narayan, I told him straight up, was like, hey, I'm thinking of, obviously continuing with the PhD, but thinking about industry after. Can we construct my PhD in a way that would enable me to do that? And he was like, yeah, I know what you mean. I got you. Let's, build something around what you want. And he was great about that. And so always, we ended up constructing my PhD in a way where I was more focused on the development side of models and algorithms, but also project leading. I led the first data release for the Young Supernova experiment. And so this is a collaboration of around 100 people, and I would be leading meetings and leading this big data release. And that, I think, was a project that I wouldn't have been put on or encouraged to do if I didn't voice that, hey, industry was something I've been wanting to do. And he was able to recognize that these are the skills that you're going to need when you make that transition. They're going to want to see what kind of projects have you led for these bigger or more powerful, or whatever adjective there, for stakeholders. And I wasn't spending my time writing very niche, like, astronomy proposals for telescopes and things like that. It was a bit more of a broader sense approach, where I wouldn't be so pigeonholed when it came time to apply for jobs. At least that was the thought, and I think it paid off in spades, because that was, project leading was definitely one of the things I think that helped get my foot in the door, at least in terms of succeeding at the interview stage.
That's great to hear. I didn't realize that was such a focused plan so early on in your grad career. Like that's really great. I know got them very well from supernova research over the years, and so he and many other faculty, understand that people have different plans through grad school, after grad school, et cetera, and are very not just respectful of that, but go out of their way to actively support that, right? There's the passive support of like, sure, if that's what you want to do, go for it, have fun. But then there's the active support of let's actually plan projects, let's actually give you responsibilities that will support this career path, which is different than sticking in academia and doing that kind of path into postdoc faculty research, whatever, et cetera. So that's great to hear. I think, clearly it worked out very well. It brings up, I think, the good point also of those skills are incredibly powerful for jobs in industry, right? I talk to a lot of astronomers that are like, well, I've done a little bit of like machine learning and played with a lot of data, and so I'm going to write that in my resume, but I don't have any of the other skills that they're looking for. And it's like, well, have you written a proposal that asked for a budget? Have you worked with a collaboration where people were in different time zones? Did you plan out the steps of a project, of when you needed to get data, when it needed to be analyzed by, when you needed, all of that kind of stuff, project management, whatever you want to call it, those soft skills, non-technical skills, those are all incredibly powerful. They absolutely should be in your resume. And certainly people are looking for that when they're hiring into a company, especially from the academic side when you're coming out of academia, because not everyone has that experience. So yeah, so that's great. I just wanted to kind of point out some of those tips. But going back to what you were talking about, you have all these skills, this experience from your grad career, which is awesome. You roll it into a resume that gets some feedback and it looks good for tech roles. So what was your experience like applying? Because it was sort of you were applying as you were finishing up and getting ready to defend, right? Those periods overlapped, I believe, right?
Yes, I did. And it was a long process. I knew that going into it, and I didn't want to, assume that things were going to go fast or well because I knew the job market was tough, and it was tough, and I think it's still very difficult. So I was slated to defend in spring of 2024, which I ended up doing. But starting in the summer of 23, I wasn't planning on starting to apply until the fall, but I got reached out to by a couple recruiters for quantitative research positions at hedge funds because they like to grab people in very technical fields and physics backgrounds and astronomy backgrounds and mathematical backgrounds and whatnot. And they said, hey, I can line up some interviews for you at hedge funds. And are you interested? And I was like, I wasn't interested before, but yeah, like let's do it. Let's get the interview experience. Let's get the practice. What are they looking for? What skills can I infer that, things that I need to brush up on, so that when I interview for companies that say I'm, really excited for, or, the dream job, quote unquote, comes along, then like I'm ready for it. So I was fortunate that, my advisor allowed me the time to study up for the interviews. So I was doing a mix of the standard like leak code problems and brushing up on the like linear regression and it like very basic but fundamentals of machine learning and statistical analysis. And I went through those interviews, never ended up getting final job offer, but got a couple rounds deep in a few of those. And that was really good experience because as I soon came to learn when it came time to apply in the fall was that it was very hard to get an interview flat out. Like I was very lucky to even have a recruiter reach out to kind of hand me some interviews on a plate. And so when I started applying heavily in the fall, it took me a while to get the right approach down. So at first, I was just sending out resumes left and right to everything. Like when LinkedIn would show, you can filter it out to say, find me data science jobs in these areas and alert me when there's a new job posting. So every morning, those new job postings would come up. I would apply down the line. Did kind of the same for, I think, Indeed and a few other these job boards. And of course, you probably can imagine that didn't merit me much success. I had a few different forms of resume, but I wasn't being as fine-tuned or tailored to the job as it needed to be. And so my success rate was I think average to poor. I mean, I was probably getting out of maybe 200 or 300 applications, I probably got, 4 interviews. So that wasn't scoring me very well. And then after I'd say a month and a half or 2 months, I was like, you know what, let's change the approach. This obviously isn't working. Let's apply to fewer jobs, but really tailor my resume for each one. Like spend an hour or something on like each tweaking the resume where as much as I could. Like if I saw that, hey, these jobs over and over again are looking for Tableau experience or cloud computing or whatever, in my spare time I try to get access and brush up on those things, so I at least had enough experience where I could safely put it on a resume as like some kind of exposure to it, where I wasn't so not in line with the job posting. And it was pretty soon after that approach where the job posting for Honeywell came up, and obviously that's the one that ended up working out. And during that time of spamming, as many as I could, I did reach out to folks who I knew had made the transition over, and if there was a job posting, I would say, hey, can you refer me? Or even I blind sent out some applications, like finding people on LinkedIn who got their PhD in astronomy, who I saw were doing data science somewhere else, and I would just shoot them cold, like a message, like, "Hey, this is who I am. Saw you made the jump, and I would just love to get 30 minutes of your time." And a few people were very gracious and responded to those, and either got on a call with me or would type up a bit of give me some message or advice. And then a few folks even did give me referrals, and some of those turned into interviews, some did not. But I was just trying to do every tool in the tool belt to get some response. And ultimately I got interviewed for the job in December, got the offer, and accepted it actually during the Astronomers Turn Data Scientists, during that time, like of the AAS meeting in New Orleans, and the rest is history.
Awesome. So what was it like then with like starting out in your new job with like getting up to speed with the like adapting to the skills that you found were required on your new job, and did anything surprise you of maybe some things you thought mattered more, some things you didn't expect to matter as much but have been important for you?
Yeah, I would say the thing that surprised me, which I guess isn't all too uncommon, especially now in like corporate world, is like corporate runs off of Excel, honestly, for most things, and that's what most people are comfortable with. And so, you might think you're going to come in and you're going to do like it's going to be set up for you to just do this like beautiful machine learning, have access to everything you want right away, and you could just dive in. And that was not the case. Of course, depends on the company, depends what their goal is. But that was certainly not my experience. It was, a lot of trying to get not only like access to things that I wanted, but trying to find where, pieces of data were, trying to get the landscape set up so that I can even do kind of these more high level, big data and machine learning projects that I was anticipating. And so it's really turned into more of, understanding the needs of upper leadership and management, and understanding what they're going to ask you to do something, whether it's, build me an application or a dashboard, or I need, we have this problem and we need to find out the systemic issues that are playing into this problem, go figure it out. And you have to understand what they mean from like a business sense, and then try and find a way where, that on the technical side, because they're going to trust you as you're the expert, to be able to build something that ultimately answers what they're asking. Because sometimes they'll ask something and you think what they're saying, or what they're really meaning, but you have to think again and again, or be like, actually, I don't think they mean this. I think if I present it in this way, then they would understand, the results better. Or he says he wants this, but actually it's the main functionality that he wants. And so I'm going to do it this way. So you're much more of like a translator interpreter, and you get kind of the free reign to, in a sense, to build what they're asking for, and they're going to trust you that you're going to know, all the steps, what the right things to do are, because oftentimes, it's not like you have a PhD advisor where on a technical side you can ask them like, hey, I don't know how to implement this model, or I don't really know what this thing means, and then your advisor's like, oh, it's just this, or like this is what this means. But oftentimes your manager, especially if they don't come from a data driven perspective or background, then they're not going to know. They're going to trust you to be independent and to collaborate with the other data folks, and to know how to put together something that ultimately answers what they're asking. And that's been the biggest change, I think, for me.
It's super interesting. That's very different than my experience as a data scientist. And this is one of those, you ask 3 data scientists, you'll get 4 backgrounds and opinions and stuff like that. I think, it's certainly, I think you hit the nail on the head when you said, your direct manager and their background and experience is a huge difference maker in these kinds of situations. I've been fortunate where my direct manager for all 3 of my jobs has been I've had many managers at each of those 3 companies, actually. So it's probably like 7 managers by this point. But anyway, they've all been very technical, very tech savvy, strong data sense, data background, et cetera. And so I felt that I could go to them with a question and be like, hey, do you have ideas on this kind of model or where I should go? And then sort of on the flip side, where I've been the manager and people on my team, they know that I have that background and they can come to me and say like, hey, do you think I could use this model? Or, do you have another idea? And I can, most of the time, I think, give them decent advice, or at least a good back and forth. But certainly I have worked with other managers and seen other folks on teams where, yeah, their manager may be not as technical, and you do, like you said, have to rely on your data colleagues to figure it out and try to be more independent in many cases. And that's in the high dimensional space that is, your perfect job. That is one of the axes, right? You want to know who is your manager, what is their background, who are the, if you're at a tiny startup and you're the only data person, you're the only data person. You got to make all those decisions and figure all that stuff and really be independent. And for some people in their, later in career or coming right out of academia, that's really exciting. Some that's super intimidating. If you go to some of the really huge companies, they tend to have a lot of data people and lots of technical managers. And, there is a little bit more, or a lot more, of the top-down advice, let's say, from the technical side. So, I just want to point out that, like, to each their own, and it's a lot of different ways that you can get there. And some of it is exciting and some of it is scary, and hopefully you can find a spot where you feel that you fit in and that it works well with your personality, or try something new, and it is challenging and scary, right? So yeah, just wanted to kind of point that out, because I've heard that situation, but like I said, I've been at different situations, which is cool. And I think one of the nice things about tech industry and data roles is it is so varied. There's so many, like I said, it's a high dimensional space of jobs. So I wanted to get a little bit more into detail, asking you, Patrick, about what you do, what the company does. I know we've talked a little bit off camera about there's some limits on what you can share with us publicly on YouTube here and our podcasting services, but sort of at a high level, what is Honeywell, or your chunk of Honeywell, doing, and what kind of skills are you applying, as much as you can talk to us about it?
Absolutely. So I work for Honeywell Federal Manufacturing Technologies, subdivision of Honeywell Corporate, the company that makes your furnaces and fans and whatnot. And they are the main contractor for the Kansas City National Security Campus. There, they make or procure non-nuclear components for our nuclear stockpile. And so they are ultimately contractor for the Department of Energy. And when I first got the job, I couldn't do too much until my clearance came in a few months later. But once the clearance came in, I was able to really get to work on some projects. And yeah, obviously, yeah, I can't exactly get into the details, but on a broad level, is there's a manufacturing side of the National Security Campus, and then there's a procurement side, we buy parts from other vendors, like other US-based companies, and all of those parts that you buy in, they get shipped to the facility, and our facility, quality is the name of the game here. So we inspect every part that comes in. There's millions of parts every year that comes through our department, and they're all rigorously tested, chemical testing, electrical testing, depends what the part is, but everything down from your typical screw to bigger things. And so my job is essentially to make that process better, more efficient. If a part is non-conforming to design, like someone ships in a part and it's bent in a weird way, and we measure that it's bent in a weird way, how does that affect the supply chain, ultimately to go into other things. And so, as you can imagine, with millions of parts and many different categories of parts and the different types of routings that those parts could go through, the the scale of the job gets very complicated very quickly. And so ultimately we need very strong tools, to like digital tools, to help us navigate the supply chain. And so ultimately, as a data scientist, that's what we're focused on, and particularly the department that I'm in.
From your experience in machine learning, from your graduate school, and then now, do you have some sort of expertise within like the types of models, classification or regression or unsupervised, or is there something that you feel you're stronger in, or are you trying to like cover all your bases? How about like the way you go about learning, or continuing to learn as a lifelong learner, going through the knowledge of machine learning?
Absolutely. So yeah, the skills that helped me the most, especially currently, is my knowledge of big data and just good data practices. Get any company to know kind of your, ML ops, or, making sure that you build a model in the right way, you test it in the appropriate way, and the first, actually going before that, how to get the data, how to clean the data, how to understand the data, because so much of it is not really documented, or it's split in different places, and data is messy. Real data is messy. Every good data scientist knows that. How do I clean data? What assumptions do I make? Like all the fundamental skills that go into dealing with big, raw, messy data has really helped, because of course the nature of this data is very different than what I was working with, because I was working with supernovae. It was time series data. So, data that changes as a function of time, and these time scales, like, typically, they range, but on the shorter side. But here I'm dealing with parts and a lot more like text-based data, which I wasn't familiar with, but again, the same principles kind of hold. And so it helped me to be effective right away in terms of knowing how to institute these good data practices, that are industry standard for a reason, and how to be even as simple as pushing your code to GitHub, or GitLab, or versioning things and appropriately naming files and whatnot. And so that was a big help with that. And then our company has resources where they have licenses for external learning through Data Camp, and there's another one whose name is escaping me right now, but lots of chances where you can brush up on a skill that either forgot or haven't used in a while, or just something brand new. And that's been good too. That I think any good company will want to help invest in you and your chance to learn, to ultimately help the business, whether that's improving with courses or certificates, or going to conferences, or just chances to share ideas with other data folks at the company. And I think that really, those things have helped immensely. So even though the nature of the data is quite different than what I was used to, and the ramifications are quite different, but it all comes back to the fundamentals, in my opinion, and those things don't change. And if you get those down, then everything else is is gravy. Like, you know, at least the next step to take, even if you get stuck at a roadblock, you're like, all right, I know I need to check on this and this, and if this doesn't work, then I need to change the approach and go this other way.
Yeah, I mean, I think I've said this probably in half of our episodes, but like, it's one of the reasons that, many astronomers and physicists make good data scientists is we have messy data just by the nature of our research. And getting those fundamentals drilled into you in grad school and postdoc research, et cetera, of be skeptical of your data, look for missing data, bias data, clean your data. That is what a lot of data jobs are. And so, exactly like you said, having those fundamentals is key. And then applying them to a new field, yeah, you learn a bit about that field or maybe a new tool here and there, but those fundamentals are key for sure.
It takes some, I was just going to say, it takes
Yeah.
some time to understand, like, intuitively, if the data you're looking at makes sense or is
Yep.
right. Because, of course, during the course of the PhD, you start to get a sense for what looks right, what looks a little strange in the data, and is that a true phenomenon that's being reflected in the data, or is that just garbage data due to some process that's made, or a million other things. And so, with the data, the type of data being so new, and again, in terms of manufacturing supply chain, I had to, I mean, I still am learning the data, but certainly that my first few months was just trying to understand, what the heck am I looking at? Because if I don't understand it on an intuitive level where I could look at it and know if this makes sense, if this is expected, then it doesn't matter if I create a model down the road, and because how would I interpret it if I don't understand the data on a fundamental level? And so, yeah, that would, I guess, be my one piece of advice. If you don't really know what you're looking at, you really got to start there first.
Yeah, I totally agree. Thinking about too, yeah, the companies I've worked for, every place, yeah, I didn't know the detailed field before I got there. And so I could get a pile of data and I could be like, maybe this looks reasonable, maybe it doesn't. And yeah, kind of that's definitely what I would say is, yeah, the kind of a huge, if not the biggest learning curve, starting any kind of job. But I think, you were hinting at this. I think, the fundamentals though are still how you do that, right? If I give you a long list of numbers, yeah, I may not know if they make sense, but the first thing I'll do, because I'm an astronomer first, is I make a histogram, right? Every astronomer I talk to, you're like, oh, you make a histogram. Does it look Gaussian? Does it look super skewed? Does it have some wackadoo outliers? Maybe that's expected in the data, maybe it's not. But like the fundamental tool of how do I visualize data? How do I decide if there's a smooth distribution, a skewed distribution, or outliers, right? Those things I think are those fundamentals that people tend to pick up, whether or not they know they're learning it in an academic research setting in something like astronomy. And then that's when I would show, to a stakeholder, a product manager, or another data person that's been at a company longer, hey, does this make sense? Does this distribute, should it be nicely evenly distributed, or should it be bimodal? Or, yeah, we expect a handful of these little outliers and that does make sense. Or, oh God, there's an outlier. Uh-oh. Right. Depending on what you're looking at. So yeah, no, that's totally, yeah, that definitely, that deep understanding is something that takes a long time and is a huge, intimidating, but hopefully interesting, right? That's where new interesting problems come from, hopefully, wherever you're working. You were starting to say like that is one of your big pieces of advice that you might give folks. I'm curious to get your highlights of pieces of advice that you would give academics that are looking to make the transition. I think you were in a very fortunate spot where you told you knew pretty early on in grad school. You shared it with your advisor. They were very, like I said, actively supportive. Folks that maybe are less sure, or folks that maybe have an advisor that isn't as actively supportive or doesn't have that knowledge base or tooling, sort of what's some advice that you might give to them of like, hey, try and learn X on your own, or go talk to this type of person, or what pops into your head is sort of some of those top pieces of advice.
Right. I would say for the resume component, whether you want to be data scientist, machine learning person, data engineer, doesn't really matter. Put on the resume that you are either expect to be, or you are like a data scientist. You're just applying it to astronomy right now. Pitch yourself like as if the astronomy, the work you do, is the company, and think about it from that perspective. What projects have you done in astronomy using the tools that explain that in a way that, as if you're corporatizing it, in a way that you frame the successes and the percent increases of accuracy, or you saved people this much time or this much money. Put it in terms that they can understand, and try and frame it through the lens of, okay, my research is a company, of one, and I'm a data scientist, and my company just happens to do astronomy. How would you pitch that? And I felt that that was a lot more successful, because even it took me a while, and I think it takes a lot of folks a while, how to really write an industry friendly resume. Because you might think, you write the resume and you think it's good, but it's still, there's way too much astronomy jargon. There's way too much, assuming that people are going to care about your papers. I'm sorry, they don't. They just want to see, project leadership. What is the impact of what you're doing? Can you explain something simply and concisely, in the way that if a human's going to look at it in their 3 to 5 second glance, are they going to catch some of the highlights that you have? And again, if you want to be something, you want to be a data scientist, data engineer, pitch yourself as it. Like, you're not a student trying to do these things. You are the profession, because there's one person who's pretending to be the thing and one person who is the thing, and they're going to choose the person who portrays himself as the thing, and you're your biggest advocate. So that's some advice that I got, and I feel really helped. And of course, just sharing your resume with people. I think I had maybe 5 or 6 trusted people who had made the jump take a look at it, and everybody had some tweaks for me, and those were all truly and invaluable advice. And so, yeah, try and reach out, even if you don't know anybody. There's people on LinkedIn you can find that, hey, they used to do astronomy, or they got a PhD at my school and something similar. Let me reach out to them and see how they did it. And the worst they can say is no. The worst thing is to not ask in the first place. So
I'm a bit curious about how the field of astronomy is today with all the recent development in machine learning, the hype from LLMs. I know when I was finishing up my bachelor's degree, starting out in grad school, I felt that I wanted to learn machine learning, but I was intimidated and I didn't even get started until my last year of grad school. And then when I finally learned it, it's like, wow, this was not that hard. I should not have delayed. This would have helped me in my research if I had learned this early on. But it seems that maybe today the field might be different. Maybe is it introducing machine learning more easily to the students who are going through, or is it impacting the research in a different way? How is the field adapting to machine learning becoming more prominent?
from my bubble, astronomy and machine learning have really married quite quite intensely, and I think more people are pro machine learning or applied to astronomy than not. I'm not quite sure when that transition happened per se, but I think everybody now, especially if you're trying to get into grad school, I think everybody has a cursory understanding and have probably applied something simple, even if it's through some prepackaged thing, through scikit-learn or whatever. I think it's machine learning is pretty ubiquitous, just because the nature of the data. There's so much data that ultimately, of course, it depends on what you're doing, but in some sense, you're going to rely on machine learning for some kind of classification, or for removing data artifacts, or providing quick inference, or if you're doing imaging of galaxies, or trying to deblend galaxies and stars, in wide field imaging, like all of that. It's now certainly very popular, and even in the last year or two, of course, with the popularity of ChatGPT and all these large language models, people are trying to turn more to this multimodal foundational model approach to astronomy, taking images and spectroscopy and photometry, and trying to weave data together in a way that we haven't before, and gain access to large computing. Depends on where you go to school, but seems to be more and more accessible, especially as they make these models smaller and smaller. So we've learned the DeepSeek recently, where it's kind of at everybody's fingertips, and there's lots of ways to go about getting your feet wet. And yeah, there's a lot of interest there. Maybe not all of it is great, or like maybe we shouldn't be doing machine learning, or we could just do a simple regression. That's a different discussion. But yeah, I think it's very popular right now, and will only continue to be popular, as especially with LLMs and advancements of diffusion models and other type approaches.
Yeah, I definitely agree. I think, alongside the techniques of machine learning, I've also seen over the past, maybe a bit longer time scale now, but the tooling, right? I grew up in grad school using IDL and IRAF, and like very at the end of my academic career, people were like, "Hey, this Python thing seems like it might be useful to use." And now Python is extremely standard in astronomy, which is great. People, like you said, putting their code up in GitHub, and actually using that for version control, as opposed to I literally had, spectrum dot fits, or, dot pi IDL, whatever, and then dot old, dot older, and dot oldest. And that was my version control, right? And so the tooling side is also, I think, come a long way, and better aligning with industry standards, which is better for the astronomy research and better for folks that are interested in making this transition. So that's been really cool to see over the last, I mean, like I said, the tooling side over the past decade, probably. So we're getting towards the end. And so one thing we always like to ask people, Patrick, is sort of, parting words or thoughts or pieces of advice. You talked a little bit about advice before, but any other things that you want to bring up to our audience, mostly folks that are interested in machine learning and various techniques, either applied to research or industry jobs, and folks that are looking to make the transition. So, what would you say, or possibly even advisors that want to help mentor their students to make this transition? So, yeah, open it up to you on what you want to tell us.
Yeah, I'd say the big takeaway, this is something I mentioned in passing earlier, is that you're your biggest advocate. If you want to apply machine learning, does it make sense to do it in terms of your project? You can try and see, and if not, maybe you can do a side project related to astronomy or something else. There's lots of open source data sets online. You just get your feet wet. To be successful, I would say, is a lot of it is self-starting motivation. And so even if you don't get that externally through friends or your advisor, you are your biggest advocate, and you're also your biggest, roadblock in a sense. You could just put yourself in the best position, and it's up to them to say yes or no. If you tell yourself no first, then of course, the thing that you ultimately want is probably not going to happen. Yeah, just trying to find out is in demand, what makes sense, and just going for it. And that, like, you have nothing to lose, and there's also not really a time limit too. Like, yeah, I mean, I made the jump right from the PhD, but there's lots of folks who go through a postdoc or two postdocs, or they go do something completely different and then find their way into data science. They go off to business school, or they do something else. And if that's the end goal, like, it's great. Doesn't really matter, the path that you take to get there, especially if you're learning and are happy along the way. Yeah, like, it's not like if you don't make it in this cycle of applications, oh, dream's over, that's it, pack my bags, like, let's go home. I've never ascribed to that methodology, and I don't think it's it really benefits anybody else to do that. So yeah, parting words, you can do it. Just kind of soul search, find out what really is important to you, and if you want it to happen, I mean, just try to put yourself in the best position to do that, because there's lots of free resources available, and yeah, people are going to want to see that you're independent, you're responsible, and you can lead a data science project. You can lead a big multi-million-dollar project with hundreds of people depending on you, and upper management really hinging on you. It's a lot there, but hopefully there's a nugget in there that you can take away.
Thanks so much, Patrick. And I'd like to thank everyone for listening to this podcast or watching our video. Please subscribe so you can find out when we release future episodes.
Yeah, thanks everyone, and thanks again, Patrick.
Thank you for having me. It was a pleasure.